This is lesson 1.5. In lesson 1.5, we're going to talk about solving equations when we have variables on both sides of the equal sign. So for example 1, if we have 10 minus 4x equals negative 9x. Just like when we have plain old numbers on both sides, we have to add or subtract to move it to the same side of the equal sign. So with this one, I don't have any common or like terms on either side at the moment. So I'm going to add 4x so that both sets of x's are on the same side of the equal sign. Negative 4x plus 4x makes 0. Bring down our 10. Negative 9x plus 4x is negative 5x. Then, to undo this multiplication, we're going to divide both sides by negative 5. And we find that x equals 10 divided by negative 5 is negative 2. Sometimes they look a little bit more complex. So then example 2, we have 3 times the quantity 3x minus 4 equals 1/4 times the quantity 32x plus 24. So just like when we have equations and there's variables only on one side of the equal, we still have to take care of our parentheses first. So we have to distribute all of our sets of parentheses. So on the left side, we've got 3 times 3x, which is 9x. And we have 3 times negative 4, which is negative 12. On the right side, we have 1/4 times 32x. And remember, this is kind of like 32 over 1. So we go across the top. 1 times 32 is 32. 4 times 1 is 4. And we keep the x. And then we do 1/4 times 24. So again, same idea. 1 times 24 is 24. 1 times 4 is 4. And that was a positive, so we're going to put a plus between them. So next, I'm going to kind of clean things up a little bit and simplify what we have here. So nothing changed on the left. 9x minus 12. We'll just bring all that down. 32 divided by 4 is 8x. And 24 divided by 4 is 6. It makes it a little bit easier, especially since these reduce to whole numbers. So again, we want to get our variables on the same side and our numbers on the opposite side of the variable. So if I'm looking at it, I'm looking and I'm seeing, okay, if I move my 9x's over here, I'm going to end up with a negative number. But if I move my 8x's over here, I'll keep a positive. So I like to try and move based on giving myself positive numbers because it kind of makes my life a lot easier. So I'm going to subtract 8x from both sides. So that gives us 0. Bring down our 6. We haven't used this minus 12, so we'll bring that down as well. 9x's minus 8x's leaves us with 1x. Now we have a regular old two-step equation. So we're going to undo this subtraction using addition. So we're going to add 12 to both sides. So negative 12 plus 12 makes 0. We're left with x on this side. 6 plus 12 gives us 18. So for this one, x equals 18. Now, something that is a little bit different that we haven't really talked about yet is that equations can give us different amounts of solutions. So when we look at example 3, we're going to take a look at how many solutions we have for each of these problems. So how many solutions? So for problem A, we have 3 times the quantity of 5x plus 2 equals 15x. For problem B, we have n over 6 equals negative n, or negative 1n over 6 plus 1/2. And for problem C, we have negative 2 times the quantity 4y plus 1 equals negative 8y minus 2. So we're going to look at these individually, but I wanted to write down the equations first. So in our first problem, A, we have parentheses that we need to distribute into. So we have 3 times 5x gives us 15x. 3 times 2 gives us 6. And we haven't used this 15x, so we're going to bring that down. We want to move our variables to the same side. So for this one, since this has a 15x and a 6, I'm going to move these x's over to the right side with my 15x. So I'm going to subtract 15x from both sides. 15x minus 15x makes 0. We'll bring down our 6. 15x minus 15x is 0. So when we look at this, we're like, hey, does 6 actually equal 0? It does not. So I'm going to put a line through there because it's not equal. And since 6 does not equal 0, for this equation, we would say that there is no solution. For problem B, the first thing that I can try with problem B, since I have my variables over a number, I'm going to try to get rid of those fractions. So what I'm going to do at the very start of this one is I'm going to multiply both sides by 6 over 1. I'm going to write down this side just because I don't have space in front of it. So when I look here, my 6's cross cancel, which means on the left side, I'm just left with 1n, or n. Now if I take this individually, so currently we're looking at negative n over 6 times 6 over 1. My 6's, again, cross cancel, so I'm left with negative n. And then if I'm looking at 1/2 and 6, 1/2 can be reduced and 2 goes into 2 one whole time. And then 6 can be reduced and 2 goes into 6 3 whole times. So 1 times 3 is 3. Now it looks like these other equations that we've worked with so far. So I want to get my variables on the same side. So I'm going to add this n. Since I already have the 3 here, I might as well move the n's over to the left side. So negative n plus n makes 0. We're going to bring down our 3. 1n plus 1n gives us 2 n's. And then I need to divide both sides by 2 so that we can get n all by itself. And when we do this, we find that n equals 3/2. So if we get a solution where the variable equals just one number, then we would say that this has one solution. And then you could share or enter what that one solution is. And in this case, it's 3/2. For problem C, again, we've got some parentheses to take care of. So negative 2 times 4y, negative 2 times 1. So that gives us negative 8y minus 2. And then we haven't used anything on the right side yet, so we're going to bring all that down. All right, so I got to get my variables to the same side. I'm going to move my minus 8 from the right side. Or sorry, minus 8y. So I'm going to add 8y to both sides. So if we look at this, negative 8y plus ay, 0. Negative 8y plus 8y, oh, also 0. So what I'm left with at the moment, if I bring everything down that's left, I have -2 equals -2. So then again, just like with problem A, I ask myself, does -2 equal -2? And in this instance, yes, it does. So for this problem, because these two things are equal to one another, then we would call this solution all real numbers. So any number that you enter for x would be true, would be true and would give you a true solution. All right, for example 4, we're going to take a look at our little sheet here. A boat leaves New Orleans and travels upstream on the Mississippi River for 4 hours. The return trip takes only 2.8 hours because the boat travels 3 miles per hour faster downstream due to the current. How far does the boat travel upstream? So what we want to look at is the distance that these two trips take are the same. So we can say that the distances are the same. So we can put them equal to one another. What we're trying to figure out is what was the speed when we were traveling upstream. So what we're looking at is we're going to use x for our speed because that's what we don't know at the moment. So, how far? Let's see. So then we have to look for important pieces of information. We have 4 hours going upstream, and then we have 2.8 hours going downstream. Also part of our downstream information is that it is 3 miles per hour faster. So as we take a look at this, we don't know the speed that the boat is traveling in either direction. So we're going to use x for that variable. But we did know that it was 4 hours for the upstream trip. So 4 hours times the speed, which is x. And then for the downstream, we took 2.8 hours. However, we did our speed that we originally had, which was x, and then it says it was 3 miles per hour faster. So we have to add 3 miles per hour to the original speed before we multiply it by the number of hours it took us. So now that we have our equation, we're going to first start by distributing. So 2.8 times x and 2.8 times 3. So that gives us 2.8x plus 8.4. And then we still have this 4x that we haven't used yet, so we'll bring that down. So we want to get our variables on the same side. I'm going to subtract 2.8x. So 2.8 minus 2.8 is 0. Bring down our 8.4. 4x's minus 2.8x's gives us 1.2x. We're going to divide both sides by 1.2. And that gives us x equals 7. So they were traveling 7 miles per hour. There we go. And if we want to know how far the boat traveled upstream, we're going to take our 7 miles per hour and plug it back into the side that talked about traveling upstream. So it was 4 times our 7 miles per hour. So in fact, they traveled 28 total miles when they were going upstream.